Hello students, welcome to our quick review in circular motion sample problems. So let's have a little recap about the useful formulas that are essential in solving circular motion sample problems. So we have number 1, which is the radius. So that's denoted by r, that is equals to the diameter divided by 2. So the standard unit for radius is in meters. The second one is we have the tangential velocity or tangential speed. So this is equivalent to the rotational speed. So this is rotational speed multiplied by the radius. Okay, so this rotational speed is actually a lowercase Greek symbol for omega. So if that is the uppercase of omega, so the lowercase for omega it looks like W, right? And this one, the rotational speed, should always be in the unit or in the form of radian per second. And the standard unit for the tangential velocity is in meters per second. Okay, and then the third formula that is useful in solving for the circular motion is what we call the centripetal acceleration. So we have here the Vt square over r. So Vt is the tangential speed and then divided by the radius. The second formula for the centripetal acceleration is 4 pi square r over t square, where t is the time at one revolution. So by the way, one revolution is one whole circle. Okay, so the time it would take to complete one whole circle. So that is in seconds. So the standard unit for the centripetal acceleration is in meters per second square, because notice that this is t square. Okay. Alright, so what if the rotational speed is not in radian per second? What if? So that's why we have to convert any value to radian. So if the given is in revolution, so to convert it to radian, we have 2 pi rad. Again, one revolution is one whole circle. Okay, one rev is equals to one whole circle. That's also 360 degrees, and that's also 2 pi rad. Okay, the second one, if you're gonna convert degrees to radian, so you just simply multiply the degrees to pi over 180. So you can now cancel out the degrees. Right? And then the third conversion, so if you're gonna convert radian to degrees, so you will simply multiply the radian by 180 degrees over pi. So you can also cancel the radian and the pi. So you can have the unit of degrees. Okay? Alright, so again, we'll solve 4 problems. So we have here the first problem. What is the speed of a ball that is attached to a string and swings in a horizontal circle of radius 2.0 meters with centripetal acceleration of 15 meters per second square? Right? So to understand the problem, let's try to visualize what is happening here. So we have here a ball, right? So the ball, this is the ball that is attached to a string. So there's a string that's attached to the ball, and then it swings in a horizontal circle. So from here, the ball swings like that. Okay. And then this circle has a radius. So this is the center of the circle, and then the radius would be this. Okay, that is the radius. So r is equals to 2.0 meters. Okay, that's given. And it has a centripetal acceleration of 15 meters per second square. So AC is given already, so you have 15. AC is 15 meters per second square. So we're gonna look for the speed of the ball. So that is the velocity or the tangential velocity along a circular path. Alright? So let's solve. So you have here the acceleration, the centripetal acceleration. Let's list first all the given. So you have AC, which is 15 meters per second square. You also have the radius of 2.0 meters. So you have to check if all the magnitudes have the standard unit. So yes, this is in standard unit. This is also in standard unit. So let's solve now. So from the formula of centripetal acceleration, so you have here Vt square over r. Okay, so to solve, you will just simply cross multiply. Okay, this is what's gonna happen. So AC multiplied by r is equals to Vt square. Right, so we can just interchange the two. So you have here Vt square, that's equals to AC r. So to cancel out the square, you will simply square root both sides. So Vt is equals to square root of AC multiplied by r. So square root of AC is 15 meters per second square and then the radius given is 2 meters. So you have the tangential velocity of 5.48 meters per second. Okay, that's the answer for number 1. So the speed of the ball is 5.48 meters per second. Alright, let's go to number 2. We have here, if a boy is standing at the edge of a merry-go-round with a radius of 2.0 meters and makes one complete revolution in 6.0 seconds, what is his centripetal acceleration? Okay, so let's try to visualize the boy at the edge of a merry-go-round. So we have here the boy, no, and a merry-go-round. So this is the merry-go-round. And then the merry-go-round, or the boy, has a radius of, have here, the radius of 2.0 meters. So it makes one complete revolution in 6.0 seconds. So in 6 seconds, the boy has completed one turn. So this means that this is the time at one revolution. Again, so capital T is time at one revolution, which means that this is the time to complete one whole circle. So we're gonna solve for the centripetal acceleration, the AC. Right, so let's try to list all the given. So given, we have the radius of 2.0 meters. And what else? We also have the time to complete one revolution. So that's 6.0 seconds. And we're gonna solve for the centripetal acceleration. So the formula used will be this one, 4 pi square r over t square. Okay, so let's solve. Solution, AC is equals to 4 pi square multiplied by the radius in 2 meters, 2.0 meters, over 6.0 seconds square. Okay, don't forget the square and the t square. So the centripetal acceleration of the boy in the merry-go-round is 0.0219 meters per second square. Okay, now let's go to the third problem. How long will it take a race car to complete a turn in a curve with a radius of 500 meters if the centripetal acceleration is 20 meters per second square? So we have here the given radius, which is 500 meters. And we also have the centripetal acceleration given 20 meters per second square. And then what is being asked here is how long. So the time to complete a turn. Okay, how long will it take the car to complete one turn? So how long if it has centripetal acceleration of 20 and the radius of 500 meters? Okay, let's list down all the given. So we have here the radius of 500 meters. And we also have the centripetal acceleration of 20 meters per second square. So we're going to solve for the time. Okay, so again, we will be using the centripetal acceleration formula, 4 pi square r over t square. So we will just simply cross multiply. So that's how we can get t square is equals to 4 pi square r over AC. Right, so now let us square root both sides to cancel out the square in the t. So you have t is equals to square root of 4 pi square multiplied with the radius r, 500 meters, then divided by 20 meters per second square. Okay, so the time is gonna be 31.42 seconds. Fourth problem. So we have here, on 11 p.m., you as a captain of the giant ship alarmingly and suddenly sees an old man paddling his little boat towards your ship. So you need to make a 180-degree turn within 12 minutes in order to avoid a sudden crash with the old paddler. So you estimate the radius of your turn to be 0.50 miles. So what is the centripetal acceleration in meters per second square needed during the turn to avoid the incident? Right, so let's try to visualize what's happening here in the problem. So we have here a giant ship, no, you're the captain of the ship. So you see an old paddler, so a little ship. So in order for you to not crash with the old paddler, so you need to make a turn, a 180-degree turn from where you are within 12 minutes. Right? So you estimate the radius of your turn to be 0.50 miles. So the radius estimated is R is 0.50 miles. So the question is, what is the centripetal acceleration in meters per second needed during the turn to avoid the incident? So AC is being asked here. Right? So let's try to look at the units of our variables. So we have the radius now. The radius is in miles. So we have to convert this to meters, because what's asked here is the centripetal acceleration in meters per second square. And the time also is in minutes. So you have to convert that one to seconds too. Okay, so first things first, let's convert our units. So you have 0.50 miles. And we know that in 1 mile, that is equivalent to 1609.34 meters. So we have here 1 mile, and then the numerator is going to be 1609.34 meters. So to cancel out the miles, so you have the value 804.67 meters. Okay, that's the estimated radius. Okay, second one is the time. So the time is 12 minutes. So in 1 minute, we have 60 seconds. So we have 12 times 60, that is 720 seconds. Okay, let's try to look at again our problem. So 180 degree is not really a full circle, right? It's not really a full circle. It's just half of the circle. So that is why the capital T should be the time at one revolution. Should be from this point up to this point. So this means that our time here, which is 720 seconds, is just half of the revolution. So what are we gonna do? In order to complete the circle, so we are going to multiply this one by 2. So multiplied by 2, we have 1,440 seconds. Again, because 180 degrees, that's 720 seconds, right? So another 180 degrees is also 720. You just simply add the 2, so that's why you have the value 1,440 seconds. So now our time at one revolution is 1,440 seconds. Okay, so now we can solve for the value of the centripetal acceleration using this formula, pi square. So 4 pi square multiplied by r over t square. So you have 4 pi square. The radius that was inverted earlier is 804.67 meters multiplied by 1,440 seconds square. So we can now solve for the centripetal acceleration, and it has the value of 0.153 meters per second square. Okay, this is the centripetal acceleration in one revolution. Okay, but then again, if we look back to the problem states that you just need to make 180 degrees. It means that you just need to make half of the revolution. So, and what we've solved here is the one whole revolution. So to get the half of the revolution, we are just going to divide our solved acceleration by 2. So that is 0.0153 divided by 2. So now our centripetal acceleration in the half of the revolution is going to be 0.00765 meters per second square. And that's our answer. Okay, thank you so much everyone. I hope that you've learned something today.